Hello guys, and this is part 2 of the lesson chemical reactions and equations. So make sure you go watch the part 1 and come to this video. Thank you so much for clicking on this video if you have. So yeah, this is writing a chemical equation. Okay, so is there any shorter way of representing a chemical equation? So chemical equations can be made more concise and useful if we use the chemical formula instead of words. So if you use the chemical formula instead of words, it will become more concise, it will become more precise, we can say, right? It will become more shorter, more let's say more easier to write, a simpler way. So if you see the formula of magnesium and oxygen, it will become as magnesium oxide, and the magnesium plus magnesium, when it reacts with oxygen, we get magnesium oxide. So the above equation in the form of symbols, it can be written as Mg plus O2. Mg is magnesium plus O2 is oxygen. If we react these both together, we will get MgO. Okay, so we have to count. So the number of atoms in each element, if they are same on both sides, they are balanced. We can call that equation balanced. So if they are not equal on both sides, that is, if the mass is not same on the both sides of the equation, it is known as it is unbalanced. Okay, because of it, the mass is different in both sides of the equation, it is unbalanced. We can call this equation as a skeletal equation. Okay. So balanced chemical equation is pretty much, if you recall the law of conservation of mass that we studied in class 9, mass can neither be created or destroyed in a chemical reaction. Let's highlight this point. So first thing is that law of conservation of mass. What is law of conservation of mass? That is, mass can neither be created nor destroyed in a chemical reaction. In other words, you can also say that is, total mass of the elements present in the products side of the chemical reaction and total mass of the elements present in the products of a chemical reaction has to be equal to the total mass of the elements present in the reactants. That is alright, I don't know why the screen is so shaky. Anyway, so it's pretty much that it's just that it's pretty much that's it. Mass can neither be created or destroyed in a chemical reaction. So we can also say that the number of atoms in each element remains the same before and after a chemical reaction. So for example, you burn an matchstick. So before, the matchstick is 1 gram. So after you burn the matchstick, it is also 1 gram. So the mass of the matchstick before burning or before a chemical reaction and after a chemical reaction is always the same. So this is the law of conservation of mass with an example. So first let us discuss or let us learn about balancing and chemical equations step by step. So first we have zinc plus sulfuric acid. So this can be written as zinc sulfate plus hydrogen. So this you have to write it as Zn plus H2SO4, which is hydrogen and sulfate, plus we have hydrogen. Okay. And if you ask me what are the numbers and all of these, like I can't understand what are these. These are the valency. Okay, if you want to remember valency in a simple way, I'll put that as a video. Make sure you comment if you want it. Okay, so it is Zn, that is zinc and zinc sulfate. So I mean, it is zinc plus sulfuric acid, it is H2SO4, and this will be converted into zinc sulfate plus H2, which is hydrogen. Okay, this is actually a very balanced equation. This is very balanced. So if you see in zinc, you have to write it like this: element, reactants, products. Just make a table. If you say, you have to say elements, reactants and products. So in the element, what are all elements are there in here? Zinc is there. Then we can see that, and always it's not a normal thing, but always hydrogen and oxygen should be done, should be in this table in the last. So the next is sulfate. So we have zinc, we have sulfate, we have hydrogen and we have oxygen, right? So first is that we have in here zinc, it is 1, here also it is 1, so it is already balanced. So H2, that is H2, which is hydrogen. Here hydrogen is 2, here also hydrogen is 2. So this hydrogen is also balanced. So in the product side and the reactant side and in the product side, they should be equal. So, okay, so that is the thing. In SO4, that is sulfate, here also sulfate is SO4. That is, this also has none. Okay, this is also equal, it has 1 only. So that is 1, 1. Now in oxygen, you have oxygen is 4 here and this also oxygen is 4 here. So 4 and 4. So that is element, reactants and products. By this table we can easily balance an equation. You might not be so clear about this, but the more we solve, the more easy it will get. So let us see the next chemical equation. So now we saw in that reaction the number of atoms in each element is the same on both sides. That is Zn was 1. See, for example, oxygen is 4 here, and the reactant side and in the product side both is 4. So that means that this is a this is a balanced chemical equation. This particular equation is balanced. We made it balanced. So let us try to do another chemical equation here, that is Fe2O Fe3O4 plus hydrogen. Okay, let's see. They've given steps to balance. The first thing is that to balance a chemical equation, first draw boxes around each of the formula. Do not change anything inside the boxes while balancing the equation. Okay, so the equation that they've given here, we have drawn boxes. Okay, so the second step is that list the number of atoms of different elements present in the unbalanced equation. So this equation, you know that it is unbalanced. Okay, so for example, oxygen, here it is 1, here it is 4, and for another thing is that for Fe, Fe is 1 here, but Fe is 3 here. So it's a very unbalanced equation. So I told you, first you have to draw a table like this. That is element, we have reactants, and we have products, reactants and element. These are the three things that you have to make it as a table. So for example, here in this particular question we have Fe. Fe is Fe, we have written Fe. Next we have hydrogen. Okay, hydrogen. We have oxygen. Okay. So now we are pretty much going to simply balance it. So here Fe is what is Fe here? It is Fe is 1 here, but Fe is 3 here. So let us see what they do here. So this is the equation before. So now you can see that Fe, here Fe is 3, here Fe is only 1. But here if you see, this is a balanced equation. Okay. Alright. So that is, you can see that Fe is 3 here. Fe is 3 here, but Fe is 1 here. So to make this equal, we can put Fe is 3 here, right? Fe we can put it as 3. So this and this will be equal. Okay, now let's see the next one. We have hydrogen. For hydrogen here is 2. But let's see hydrogen here. It is 2. So it is already balanced. Here itself hydrogen is already balanced. So we can leave that off. Now coming to oxygen. Oxygen, here it is 4, here it is 0. I mean, it's 1, sorry, not 0, it is 1. But now this oxygen, what did we make it to make it balanced? So you can't put oxygen, that is you can't put 4 right here, you can't put 4 here, you can't put 4 here. You have to, if you want to make this particular equation balanced, oxygen 4 is there, you have to put 4 here so that you can make this equation balanced. Okay, now it's not done. You have balanced this situation, balanced this equation. This is a balanced equation. You have balanced this equation perfectly, but another thing that you have to do is you have to make it, you have to write symbols of the physical states. That is, carefully examine the above balanced equation. Does this equation tell anything about the physical state? So that is, for example, to make an equation more of a balanced one, you have to write if it's in the gaseous, liquid or aqueous or solid states of the reactants respectively. So the word aqueous is for AQ. Let us highlight this. The word aqueous is for AQ, is written in the reactant or product is present in the solution. If the solution is pretty much in water, that is, if you put a salt NaCl, that is salt in water, you will get an AQ, because the particular if the reactant or product is present in water. If it's present in water, it is known as an aqueous solution. So the balanced equation will become, for this one, the balanced equation will become, so this is the equation that we had solved previously, but now this is the equation that we have put by putting the symbols. So for example, Fe is a solid, so we are putting this Fe as S, and if it's gas, that is H2O is a gas, right? So we are pretty much putting G. And next Fe, for the Fe, this part we are putting S again, and for this we are putting gas. Okay, I mean hydrogen, right? Hydrogen is gas. Okay, And you might be wondering that why in a G is used here, that is H2O is water, right? It's pretty much a liquid, right? Why are we using G here? Note that the symbol G is used with H2O to indicate that in this reaction water is used in the form of steam. Okay, so in H2O here, because if we use distilled water, right? So it's used in this form of steam. So that is the reason by which we are using G, that is the gaseous symbol for H2O in this particular thing, okay, in the particular equation. Alright, so usually physical states are not included in a chemical equation unless it is necessary to specify them. So these states are not necessarily, it has to be, it's not necessary, but it's better if if they ask you to do it, you have to. So it is necessary to specify them. Unless it is they mention it, it is unnecessary to specify them. Okay, alright. So sometimes the reaction conditions such as temperature, pressure, catalyst, etc. for the reaction are indicated above or below the arrow in the equation. So you can see that the catalyst is above or below the equation. Sometimes it is given, but it is not very important for you to learn it now. So it is COG, okay, that is pretty much it. Yeah, just make sure you go through it once. You can see that it's mentioned glucose and all that. Here sunlight, chlorophyll, what is happening in this particular process, they've written it. Like what is happening from shifting of this to this, what is the process happening, sunlight and that chlorophyll, and this is the glucose, so that's why they've written it that, and all of these 340 18 of that, okay. So all these questions are there, right? These questions I'll be solving after in another video. So for this video I'm ending it right here. This is part 2 of the video, signing off, and make sure you watch the part 3, which will be uploaded as soon as I complete it. Thank you for watching this video. Make sure you watch all of them to get the perfect understanding and tell me what I should correct in making my videos. Thank you for watching. Bye.